Okay, so let's wrap up section 10.1 by doing some graphing. So we're going to graph some functions. I'm going to start first with square root functions. Remember, the fact about these types of functions is that we have to worry about square roots and negatives, so the domain will be impacted. So before we graph them, we probably should look at the domain first so we know exactly what to plug in. So for this first function, we have the square root of x plus 3. So I need to make sure that the x plus 3, the radicand, is either greater than or equal to 0. It has to stay positive. If it remains positive, I'm not putting this bad situation in there. So subtracting 3 from both sides, my domain is anything bigger than negative 3. So interval notation, we've got that. So when I start putting values in here, we can start with negative 3. The square root of negative 3 plus 3, which is the square root of 0, which is 0. So there's my first initial point on this graph, because that's the first initial data point where the interval is good. And then we can pretty much put anything we want past negative 3. I would recommend you put in some values that would give you some nice radicals. So put your thinking caps on. I think negative 2 is another nice value. The square root of negative 2 plus 3 would give us the square root of 1, which is 1. So a nice, neat value there. If I thought ahead, I think another nice value will be positive 1, because the square root of 1 plus 3 becomes the square root of 4, which is 2. All right, and then even if we were to get unlucky enough and put a value that's not nice, maybe my favorite number is, let's say, 3. And so we're looking at basically the square root of 3 plus 3, which becomes the square root of 6. So this is very real, right, where it's not a negative, it's just not nice. So if I'm estimating this, this is like the square root of 4 is 2, and the square root of 9 is 3. 6 is closer to 2, so maybe it's 2.3 or 2.4-ish. That would give me a nice ballpark figure, so I'll just say 2.3-ish. Alrighty, and if you wanted to be more accurate, you could bust out a calculator and kind of figure it out. Again, I don't want to use a calculator. I'm getting you guys trying not to use it so much. So that's how I would do this. So I have 4 points I can graph. So when I go graph them, it all starts at negative 3, 0. That would be the first point on my graph. The domain is everything greater than negative 3, so I'm not worried about over here. Negative 2, positive 1 is the next point on the graph. 1 and 2 is the next point on the graph. And then we have 3, and about 2.3 is another point on the graph. So you can start seeing a pretty good pattern. It looks like as we continue to move bigger with our x values, the function is going to slowly start rising like that. And so that's a classic square root graph right there. Classic situation. So we got that. For the next one, we've got square root of x minus 1 minus 2. So again, as far as my domain is concerned, there's the only piece that I'm worried about. I want to make sure that x minus 1 is greater than or equal to 0. And so when we put that in there, if we add 1 to both sides, we get x is greater than or equal to 1. So interval notation, everything starts off at 1. So when I start putting my table of data together, I'll start off with 1. Of course, it becomes this. 1 minus 1 is 0, so we get the square root of 0 minus 2. And so we get negative 2 out of that. So there's one of my first data points. Again, be careful with what values of x you throw in there. Try to put something that's nice. So we start off with 1. 2 would probably give us another nice value, right? Because 2 minus 1 is 1. 1 minus 2 is negative 1. So there would be the output. I think 5 would be another good value, because the square root of 5 minus 1 minus 2. This would give us the square root of 4 minus 2, 2 minus 2, which gives us 0. And if we just keep going on, again, if I think of nice values, I believe we said 4. How about we use 10, right? So the square root of 10 minus 1, that would be the square root of 9 minus 2, which is 3 minus 2, which is 1. Okay, so there's some values coming out of that. So when we go graph, we have 1 and negative 2. And we've got 2, and negative 1. We got 1, 2, 3, 4, 5, and 0. And then we have 6, 7, 8, 9, 10, and 1. So you got that nice square root feature going on there. So that would be the graph of that. And again, nothing's going to be on this side of the graph because our domain starts off at 1. So there's a couple of changed up square root functions for you. Okay, and let's go handle some crazy cube root situations.